Thank you.
Hi everyone, we are Team Codeless Coder. I am Sumit alongside my colleague Sukanya. As our team name suggests, Codeless Coder, we challenge the traditional way of thinking about code. Can you imagine a world where having just a test plan is enough to generate your test code? Well, welcome to the world of generative AI. We have developed the Gen AI Code Generator, a tool that translates your test plan into code specifically built on the SpyTest framework. That's why we say test plan is all you need. How do we do that? We leverage the power of large language models, that is LLMs, and specifically we are using CodeLlama Instruct 7B model. This is a state-of-art model fine-tuned on the Llama model architecture to perform code generation task. The keyword instruct means that we can provide the model with clear instructions, enabling it to generate code based on specific prompts. 7B stands for 7 billion parameters, and it is a scaled down version of Code Llama Instruct models, which is available in 13B, 34B, and 70B parameter size as well. We choose 7B model since it takes smaller GPU RAM size to train the model. As the first step, we loaded the model and gave it a little encouragement, telling it, "You are an expert programmer capable of generating code based on user requests." Then we asked, "Hey, can you write a program to create a VLAN interface?" The model responded with a code snippet using Linux command to configure a VLAN interface. While it was technically correct, it didn't quite meet our needs or expectation. So how did we make the model learn the SpyTest API? To get the model to generate the right code, we needed to teach it the SpyTest API for creating a VLAN interface. To do this, we fine-tuned our base LLM using PFT technique. PFT stands for Parameter Efficient Fine-Tuning. PFT is an advanced fine-tuning method that allows us to adjust a pre-trained model with fewer parameters and lower computational resources compared to traditional fine-tuning. This makes the process faster and more cost-effective. There are several PFT techniques, and one of the most popular is LoRa. LoRa stands for low rank adaptation. In this method, we introduce low rank matrices into the model. These matrices modify only specific weights with a low rank approximation, allowing for more efficient adaptation without needing to adjust the entire model. To train any model, we need dataset. In our case, the dataset consists of instruction sets, specific prompts designed to teach the model how to generate the correct code. Here are a couple of examples of the instruction sets we created. The first one being, we gave instruction to create a VLAN interface, gave it the SpyTest API and the corresponding code. We also gave an instruction to assign IPv4 address to the VLAN interface, provided it with the API and the corresponding code. We used these custom instruction sets to fine-tune our base model, teaching it how to correctly use the SpyTest API for VLAN configurations. After training, we loaded the fine-tuned model, gave it a little encouragement as an expert programmer, and instructed it to write a code to create a VLAN interface. It generated the code, nothing too surprising since we had already provided similar code in the form of instructions. But here's the big deal. Our fine-tuned model didn't just repeat the code, it learned the logic and structure behind it and generated the code on its own tailored to our request. Next, we asked the model to create a VLAN interface and assign an IPv4 address to it. And guess what? It generated near perfect code. Now again, we asked the model, create a VLAN interface, assign an IPv4 address, and set the interface to an admin upstate. And once again, it generated near perfect code, showing that our fine-tuning process was really paying off. But there is an important takeaway. We need to keep encouraging the model before we give it instructions to generate code. When we do, it delivers excellent results. If we skip this step, the code quality drops. It seems the model responds best to this positive reinforcement, a reminder that interacting with the model in the right way is key to getting the best performance. Unfortunately, due to time constraint, we could not perform a live demo today. But for those of you interested in exploring further, we have uploaded the train model and its corresponding dataset to Hugging Face. You can easily access it by searching with keywords mentioned here. Feel free to load the model, give it a try, and experiment with generating code based on your own instructions. To further improve the model, there are two key steps. Firstly, we need to train the model on the full set of spy test code. By doing this, we can provide it with better context and help it understand the entire framework more comprehensively, leading to more accurate and context-aware code generation. Secondly, we need to create more instruction set to cover the entire range of SpyTest API. This step will help us fine-tune the model further, making it more robust and adaptable for different use cases. And with that, we have reached the end of our presentation. Thank you for your time and attention.
All right. Thank you, Broadcom. Anything else you want to add, Sumit?
No, nothing. I'm open for Q&A.
Good. Okay, awesome. Judges, questions to Broadcom?
Is this fine-tuned on the GPU or CPU? The
I
Code
have
Llama model?
yeah, I have used a Collab notebook to train it.
Okay, so what is the data set size? It's just that two data set that you trained the model
No,
with,
it's
or?
not. Two of them are the examples I have shown. We have about 12 instruction set. So we did a kind of POC
Okay.
using 12 instruction sets.
Yeah. So did we explore the latest 3.1, 3.2 models as well? Because people, seeing enhanced accuracy on the newer models than the old Code Llama model. So did you guys look at that as well or no?
No, the newer model or the models with more number of parameters, it needs a bigger GPU size to train.
Okay.
So from POC point of view, we are just trying to demonstrate what can be done.
Okay. So from the accuracy standpoint, right? One is that the full model training and all those things with the LoRa, uh, LoRa, QLoRa, whatever. So what is the accuracy? Like, did you have to add code on top of what is generated, or like how is the accuracy you encountered in the hackathon? Like you always get the complete code, or you have to like append some code on top of what is generated, or like, because we generally the accuracy of LoRa itself is low when you have more data sets, right? You fine tune with the model. I just want to know
Yeah,
what is
so
your
yeah.
experience with
So
that.
as we know, like this InstructB model itself is a code generator model, right? So
Yeah.
uh, it has its own accuracy. So that's one thing. Then we
Okay.
are just fine tuning on top of it so that it is more context aware from the point of view of spy test infra, and uh,
Okay.
measuring
So it could
accurate.
be any code, right?
Yeah,
It
it
could
could
be
be any
any.
code.
Yeah. Okay. All right.
So it's more
Thank you.
about building a more context, and this model, fine-tuned model, is more about writing test code based on spy test infra.
Okay. All right. Thank you.
Yeah, it's a very good tool. I understand it's not a choice of what AI tool that you use, but how useful it is for Sonic development. Probably, can we also improve this to um, trigger the tests and give the test results? That's also possible, right? Based on the scenario that you want to test, it generates the scripts, and it also triggers the running of the tests, and then can generate the test results, right?
Yes, definitely, a lot can be done. It's a LLM, so their options are limitless. Uh, right now,
Yeah,
we only
triggering is something we can achieve with only with the AI agents. These are all static models. It can generate stuffs, but it's not really going to trigger anything. It can give you instructions or responses.
That's an
That's about it.
automation on top of it. Yeah,
Right. Yeah.
is those
yeah,
more of I can say software engineering.
correct.
Mm.
Yeah, thank you.
All right. Thank you so much, Broadcom.